Okay, we are going to start by reviewing the three main trig ratios that you learned in Integrated 2. In order to use the trig ratios, it must be a right triangle, and it all depends on which angle they are talking about. It's all relative to the angle theta that they want you to use. So in this picture, theta was given in this corner, but it might not always be that corner, or it might be the other corner. So it all depends on where theta is. Once you find theta, if you draw an arrow to the opposite leg, that side is labeled opposite. The hypotenuse is always across from the 90 degrees. It's always that slanted side. And the adjacent is the one that's left over, or it's the one touching theta and touching the 90 degrees. Adjacent means right next to. It's right next to theta. So always label your sides, opposite, adjacent, and hypotenuse, depending on which angle the question is about. So in Integrated 2, you learned your three trig ratios, sine, cosine, and tangent, and you learned a little acronym to help you remember it. So, TOA, hopefully that sounds familiar. And what it means is the first letter tells you the trig function, so S for sine theta. The middle letter tells you what's on top of the fraction, so O for opposite. And the third letter tells you what's on the bottom of the fraction, so H for hypotenuse. So CA means cosine theta equals adjacent over hypotenuse. TOA means tangent theta equals opposite over adjacent. The middle letter is on top and the third letter is on the bottom. So I am counting on you to be able to remember your SOHCAHTOAs from last year. Notice they're all written over here as well. Then what we're introducing this year is our reciprocal trig functions. These are the reciprocals. There are actually 6 trig ratios. The way we get to the reciprocals is by flipping over the original trig function. So reciprocal means you just flip the fraction upside down. So these are partnered up right now. You're going to have to be able to partner them up for yourself on test day. But the way they partner up is cosecant. You can see at the bottom, CSC, the way we say that is cosecant. Cosecant theta is the reciprocal of sine. So instead of being opposite over hypotenuse, you flip it over and it's hypotenuse over opposite. Secant theta is the reciprocal of cosine. Instead of being A over H, it's H over A. Cotangent is the reciprocal of tangent. Instead of opposite over adjacent, it's adjacent over opposite. So all you do is take the original ratio, the original answer, and flip it over. You don't make it negative or anything like that. You just take the numbers that are there and flip them over. If it's negative, it stays negative. If it's positive, it stays positive. So my suggestion is not that you remember 6 trig functions. If you've got the SOHCAHTOAs memorized good enough, all you need to be able to do is memorize who goes with who. So this is how I remember it. It's not like a mathematical strategy. It's just how I remember what reciprocal function goes with who. First of all, tangent and cotangent, I really hope you can memorize those as being partners, right? They both have the word tangent in it. Tangent and cotangent, they are reciprocals of each other. If I look at the remaining ones, sine does not start with the C, but cosecant does start with the C. Cosine does start with the C, and secant does not start with the C. So what I do to help me remember is out of the sine, cosine, cosecant, secant, the partnership, only one of them starts with the C. So if I'm trying to find a partner for sine, since sine does not start with the C, its reciprocal must start with the C. That's just something that I've used to help me memorize who goes with who. Whatever you do, you need to be able to come up with the 6 trig ratios on test day. In order to do that, we also need to review Pythagorean theorem. So Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. C must be the hypotenuse. This only works on right triangles. So we want to be extra careful that c is always the hypotenuse. So let's work on finding x in number 1. So first of all, hypotenuse is x. So it doesn't matter which order you do the a and the b. It doesn't matter which one you call a and which one you call b. 15 squared plus 8 squared equals x squared. 15 squared is 225, plus 8 squared is 64 equals x squared. This is 289 equals x squared. Square root both sides. You might not know, but the square root of 289 is actually 17. So the missing side is 17. I would label this with a 17. Number 2, hypotenuse. Find your hypotenuse. So x squared plus 5 squared equals 10 squared. Make sure your hypotenuse is always on the equal to side. So this is x squared plus 25 equals 100. Subtract the 25. X squared equals 75. Square root both sides. 75 is not a perfect square, so I'm just going to leave it as root 75. Your teacher will let you know if you need to reduce that. Simplify is the word I want, if you need to simplify that or not. But that is not what this video is about, so I'm going to leave it as root 75. Okay, on the next page or the next section, we're actually going to use these same triangles again. So remember what we got. So we already found the missing side. This side was 17. We just did that math on the other page. And this side was root 75. Okay, the whole reason to do that is to find the exact values of the 6 trig functions. So here we go, SOHCAHTOA. I'm expecting you to be able to come up with sine, cosine, and tangent. Now, can you come up with their reciprocal partners? Tangent goes with cotangent. Hopefully everyone gets that one right. Sine starts with an S. Its reciprocal starts with a C. That's cosecant theta. Cosine starts with a C. Its reciprocal starts with an S. That's secant theta. Okay, where is theta? Here's theta. Draw an arrow. That gives you the O for opposite side. The slanted one is H for hypotenuse, and the one that's touching theta is A for adjacent. Sine, so O over H. O over H. I'm just grabbing the numbers that are labeled O and H and writing them in the correct order, O over H. So then my answer for cosecant, I just flip that fraction upside down. Cosine, K, A over H. Then its partner, I've already done the work and partnered it up. Its partner is flipped over, 17 over 15. Tangent, TOA, 8 over 15. Cotangent, flip it over, 15 over 8. That's it. This is what we're doing. So again, we already did Pythagorean theorem on number 4. Obviously, they're right there on the screen, but see if you can start partnering them up without any help. SOHCAHTOA. Tangent goes with cotangent. 1 C in each partnership. Okay, find theta. Arrow, O for opposite. Slanted one is H for hypotenuse. The one touching theta is A for adjacent. Sine, O over H. 5 over 10. This we do expect you to reduce, 1/2. Flip it over and you get 2 over 1, or just 2. You're welcome to put over 1, or you can just write 2. Cosine K, root 75 over 10. Flip it over, 10 over root 75. TOA, O over A, 5 over root 75. Flip it over, root 75 over 5. Okay, now we have to do this one. We didn't do this one yet. See if you can do Pythagorean theorem for this triangle. So remember, hypotenuse is what it equals. So it doesn't matter the order. X squared plus 2 root 3 squared equals 10 squared. X squared is x squared. Okay, when you square something like 2 root 3, you square the 2, which is 4, and you square the root 3 and it crosses out, and it just leaves you with a regular 3. Equals 100. I'm not done though. X squared plus 4 times 3 equals 12. Equals 100. Subtract the 12. X squared equals 88. Square root, x equals the square root of 88. That's this side. Now that I have everything, here's another chance for you to set up your 6 trig functions, trig ratios. Sine, cosine, tangent. Tangent goes with cotangent. Secant, secant. Okay, look at where theta is. arrow to the opposite. Hypotenuse is slanted. Adjacent is the one remaining. See if you can fill these in. I'm going to pause it, and when I pop it back up, all the answers will be on the screen. Okay, there you go. Sine is 2 root 3 over 10. Flip it over for cosecant. Find cosine, flip it over for secant. Find tangent, flip it over for cotangent. Hopefully this isn't too bad. You just got to memorize who goes with who. Then sometimes we can ask the question differently. So find cotangent if sine is 2 over 5. So we didn't draw the picture for you, right? So just draw yourself a stereotypical right triangle. Maybe use straight lines when you draw your triangle, your call. I'm not going to. Okay. Right triangle. Decide where you're going to put theta. Label your sides. So if theta is there, this is O, this is H, and this is A. And then look at what they gave us. They gave us sine. So they gave us O over H. So O must be 2 and H must be 5. Now you know you need to find A, x. So practice your Pythagorean theorem. Remember the hypotenuse is always the equal to side. So x squared plus 2 squared equals 5 squared. X squared plus 4 equals 25. X squared equals 21. Square root, x equals the square root of 21. Notice in this example, they only want one thing, cotangent. But I just got through telling you, I don't recommend you memorize all of them. You're welcome to. Go ahead. If you like to memorize them all, go ahead. But for me, I'm going to find tangent theta first because that's the one I'm good at. I've been doing SOHCAHTOA for a long time now. So tangent, TOA, 2 opposite over adjacent. Then I'll find cotangent theta just by flipping it over. And that's the one they wanted, right? Make sure you only answer what they asked for, but that's how I found my answer. So see if you can draw a triangle to go with number 7. Generic right triangle. Put theta in a corner based on where theta is, O, H, and A. Okay, they gave me cotangent. If that's the answer to cotangent, then tangent is 3 over 4, flip it over. Tangent, TOA, O over A. So O is 3 and A is 4. Pythagorean theorem, or you might recognize this as a Pythagorean triple. 4 squared plus 3 squared equals x squared, h, however you want to do it. This is 16 plus 9, which is 25. When you square root that, you get x equals 5. That's a Pythagorean triple. It shows up a lot. And then remember they wanted cosine theta. I'll write it down here. Cosine theta. That's a regular SOHCAHTOA 1 ka, a over h, 4 over 5. So draw the triangle, label it correctly, find the missing side, and then find the one trig function they're looking for. Okay, so this is your 6 trig ratios or trig functions, and this is what you should be able to do today. Hope this helps.